Hello and welcome to the final part of problem set 7, where we have this 2.3 revenue auction types and double auction. And here I'll be discussing question 1. Assume you have a rare record of Thomas Molodini and you want to sell it and donate the revenue to a charity. You found a group, Georgian fans of Thomas Molodini, and an anonymous poll to figure out the distribution of willingness to pay or valuation for your record, and found out that there are n potential buyers and their valuations look independent from each other and are given by this. So this is not the valuation, but this whole thing is the valuation. However, this V term determines what this W term looks like, and this V term is distributed uniformly from 0 to 1. So the question is, what will be your expected revenue if n equals 10 and you decide to use second price sealed bid auction? So they want us to find the expected value of our revenue, and revenue is equal to the price we receive, and the price is actually the second highest valuation, because this is the second price sealed bid auction in which everybody bids their valuation, and of course the highest valuation guy wins, but they will only have to pay the second highest bid, which would be the second highest valuation among these people. So similarly to the previous one, we have to write something like this. So we want expected value of, if we invent a function, so if we invent this kind of function, so second highest, so expected value of this function that returns the second highest value from these valuations. So how would this expected value formula look like? It's basically integral from 0 to 1 for this, let's call it x, multiplied by fx dx. Here x is this. So we want the probability density function of the second highest function that basically returns the second highest of these values. And as you may remember if you watched the previous recording, the probability density function is the derivative of the cumulative distribution function, and the cumulative distribution function is, for example, cumulative distribution of x is just probability of x being less than this x. So we just have to plug this here and find how the probability function, so how cumulative distribution function looks like for this second highest value of v1, v2, and vn. So what we need to do here is to understand actually what scenarios there can be. So here, in which scenarios would this be less than x? So one scenario is when every single of these values is less than x. This means that, so we can express it like this, so we can express it either by the maximum value of v1 to vn is less than x, or we could have just written that v1 is less than x and v2 is less than x and v3 is less than x and so on, doesn't matter. But this is only one scenario. Another scenario is when, for example, one of the valuations is more than x, however everybody else is less than x. So for example, there could be a scenario where v1 is more than x and everything else, so let's write it like this: maximum v2 to vn is less than x. However, this was the case for v1, But we can write the same case for v2, v3, v4, and so on until vn. So there'll be n number of these such cases, and one case when all of them are less than x. And all of these cases satisfy this inequality where this is less than this. So basically what you need to do is to take the probability of each scenario. So probability that everybody is less than x, probability that one of them is more than x but everybody else is less than x for every single v, and then sum the probabilities up, and that will be this probability here. So how would you actually write this down to solve it? So actually the probability would look like this. So the first scenario would be this. The probability that maximum v1 to vn is less than x. And then we write this symbol. This is the AND operator. It just means that, sorry, not the AND operator, I messed up. So we want the OR operator, which just means that either this scenario occurs or whatever I write here. So the other scenario is, for example, v1 is more than x and max v2 to vn is less than x. So this means that, so let's take this as one scenario. So in this scenario, one of the valuations is more than x and the rest of the valuations are less than x. And here, if you combine these two, this means that either this is true or this is true, and we're finding the probability of this, basically. But this is just one of the scenarios. We have to add the other n amount of scenarios as well. So we want the scenario for v2 as well. So here we would write another OR operator. So v2 is greater than x, and v1, so without v2 now, so v1, v3 to vn is less than x, or, and so on, you add v3, v4, v5, so on, until you reach vn is more than x and max v1 to, now you omit vn from here and you write vn minus 1 is less than x. So to calculate the probability that the second highest is less than x, second highest among v1 to vn is less than x, you have to write the probability like this. And then what you can do is, instead of writing these OR operators inside the probabilities, you can actually write the probabilities as sums. So instead of writing OR, you can do probability max v1 to vn less than x plus probability that v1 is greater than x and max v2 to vn is less than x, and so on and so forth, plus vn is greater than x and maximum from y1 to yn minus 1 is less than x. Now we can look at this, and this is just probability that v1 is less than x multiplied by probability that v2 is less than x, so on and so forth until probability that vn is less than x. This is because for this to be true, well, all of them should be less than x. And probability that v is less than x is, if you look at v1's distribution is from 0 to 1, you write here x, the probability that it's in this area, when you know it's in this area, like it could be from this area, probability it being here is this length divided by the whole length, which is x over 1, so it's just x. So this is just x times x times x n times, so this is just x in the power of n. Here we have max v2, so on and so forth until vn less than x. This is just basically again probability that v2 is less than x, probability of v3 is less than x, and so on so forth multiplied on each other. And the probability would just be the same, x. So here is just x in the power of n minus 1, because we only have n minus terms here, multiplied by the probability of this, because we have here end operator, that's why we multiplied. And the probability of this being greater than x, so if you write here 0 to 1, here you take x. The probability that it's greater than x, so it's in here, it's just this area divided by the whole area, which is 1 minus x divided by 1, so it's 1 minus x. So here it's 1 minus x. And so we have this for every single scenario. So here we would have x n minus 1, 1 minus x, and so on and so forth. N minus 1, 1 minus x. And the amount of times you will observe this would be exactly n. So the sum of this will be n times x, n minus 1, 1 minus x. And you have to add this to it. So xn plus n x n minus 1, 1 minus x is the probability that the second highest is less than some value x. And basically this is the cumulative distribution function for this second highest of these valuations. Maybe I can simplify it a bit. So xn plus n xn minus 1 minus n times x n minus 1 times x, which is n times n xn, n times xn, which is 1 minus n xn plus n times xn minus 1. Now we should just derivate this. So the derivative would be n times 1 minus 1 n x n minus 1 plus n minus 1 x n minus 2. And then we need to integrate this, right? Okay, so we need to integrate this. So we want integral from 0 to 1 x times fx dx. The fx is this. We plug this here. So we write here from 0 to 1 n1 minus n xn. And let's separate this. So xn dx plus 0 to 1 n minus 1 x n minus 1 dx. So this would be what? This would be, so we take out the constant, and what's left is xn, so you write xn plus 1 n plus 1 from 0 to 1, which is, so it's 0, so you just need the 1, so you need n1 minus n plus 1, so that's what I got there. And here, so we take n minus 1 out, and we get integral of this is xn over n from 0 to 1. So here, plug here 0, nothing, plug here 1 over n minus 1. So what we get is n times 1 minus n over n plus 1 plus n minus 1, which should be plus 1 n minus n squared plus n squared minus n plus n minus 1. So this dies, this dies, this die, and it's n minus 1, n plus 1. So the expected value of the second highest value is this. So n minus 1, n plus 1. So moving back here, so we know that expected value of this, the price they pay, or the, not the price, but the, basically the, yeah, of this thing is n minus 1, n plus 1. And we just plug here 10, which is 9 over 11. And we use this here to calculate V, which is 100 plus 110 times 9 over 11, which is 100 plus 90, so it's 190. So our expected revenue in this case is 190, and that's the answer for this question.